So here were our findings. On arithmetic skill, all three of the intervention conditions performed better at post-test than the control group. So word problem solving with language instruction, word problem intervention without the language instruction, and the number knowledge condition all outperformed the control group. And you can see what the effect sizes were, and those numbers indicate that the effects on arithmetic skill were moderate to strong. So how did they do on word problem solving? Well, both word problem solving groups did better than the control group. And you see the green effect sizes of more than one standard deviation. Those effect sizes are large. However, the number knowledge condition, even though they did nicely on arithmetic, they did not outperform the control group on word problem solving. And the last line of this slide shows you that the two word problem conditions were significantly different from each other, with the word problem condition that received the language instruction outperforming the word problem condition that did not receive word problem instruction. And we also measured at the end of the study children's understanding of word problem language. And on this outcome, it was only the word problem condition that received explicit language instruction that outperformed the control group. And that embedded language condition also outperformed the other two conditions. And the difference between the two word problem conditions, with and without language instruction, was a moderately strong effect. So just by learning the math components of the schema-based math components of word problem instruction, they did not improve better than the control group or the number knowledge group in terms of their understanding of language. So what you see here, which I'm going to explain to you, is that in all three of these panels, you see one of the intervention conditions in contrast to the control group. So we have number knowledge versus control in the left panel, upper panel. We have word problem versus control in the right panel, and we have word problem with language versus control in the bottom panel. In all three pictures, you see a green descending arrow. And that's on the right-hand side of the triangle. And what that tells you is that students it's going from word problem language to word problem solving. So in all of these pictures, if students had stronger word problem language, they had stronger word problem solving outcomes. And in the two conditions where we had word problem intervention, the upper right panel and the lower panel, we also have a green horizontal arrow showing you that the intervention versus control contrast outperformed, the word problem condition outperformed the control group on word problem solving. But where the bottom panel, which is the word problem plus language versus control contrast, is green, whereas the other two pictures are not green, is in the ascending green arrow. And there what you see is that is the only condition where word problem language versus control produced better word problem understanding of language. And as we see, better language is related to better word problem solving. So what are the implications for intervention from this study? Well, one thing that we learn that's important for schools is that on word problem solving, number knowledge intervention does not provide added value over control. And this is despite that number knowledge intervention does improve arithmetic skill. So this illustrates the point that I made earlier on in this talk, that we can't assume that just because children's calculation skill is improving, that that will be enough to produce better word problem outcomes. And transfer from arithmetic to word problem solving is not sufficient to support word problem solving development. Instead, for at-risk learners, explicit structured word problem instruction is required. The second implication for intervention is that on word problem solving, embedding language instruction in word problem intervention offers added value over word problem schema instruction alone. And the third bullet is that this added value accrues as a function of children's improved understanding of word problem language, which is what's illustrated in that slide. So the next step in this line of research, we're asking, does a link between word problem solving and reading comprehension via language comprehension, does that provide direction for understanding difficulty that occurs across word problem solving and reading comprehension? So there are many students who have difficulty when they have difficulty with word problem solving. They also experience difficulty with reading comprehension. And what we're doing in this next step in this line of work is testing the effects of intervention that explicitly connects word problem solving and reading comprehension via language comprehension in a sample of students who concurrently experience difficulty in word problem solving and reading comprehension. In this study, which is ongoing, we have 3 study conditions. We have direct skills word problem intervention with embedded word problem language instruction. Our second condition, the focus is reading comprehension intervention with embedded reading comprehension language instruction. And then we have a control group. And we're conducting 2 tests of what we call the comorbidity hypothesis, whether there's a connection between word problem solving and reading comprehension learning disabilities, by seeing whether reciprocal effects occur. What I mean by that is when we teach word problem solving intervention with a focus on language, do we simultaneously improve reading comprehension outcomes? And when we teach reading comprehension intervention with a focus on language, do we improve word problem outcomes? So, and we'll also look to see whether language comprehension improvement serves as a mediator of those reciprocal effects. And if that's the case, then we would conclude that language comprehension does connect word problem solving and reading comprehension. And importantly for teachers, we can effectively leverage that connection to improve performance in both domains in a coordinated fashion. So we can improve word problem solving and reading comprehension in a coordinated and efficient way. So I'm now going to transition to give you more information on our word problem interventions. Each of our word problem, we have a series of word problem interventions, and they all rely on schema instruction, and they use similar strategies as the ones that I showed you when I described our first grade study. A schema is a category that encompasses similar problems. It's a word problem type. And schema instruction encourages students to understand word problems as belonging to word problem types. And once they identify the word problem type, that gives them good information to rely on a strategy they've been taught for solving each problem type. So at the primary grades, we call our word problem solving interventions pirate math. We rely on similar strategies to the ones that I showed you, using the main three problem types, total, difference, and change, that represent word problems in the primary grades. We teach students to classify word problems into problem types. We use a problem model for the identified word problem type to generate a number sentence. We teach children to find the missing quantity in the number sentence, much as pirates find X on a treasure map. We use a pirate theme throughout the program to kind of reinforce and motivate the kids. We use things like treasure maps, treasure chests, talk about X marks the spot. Our programs have been validated using randomized controlled trials, which show that students' word problem solving and arithmetic, as well as their understanding of pre-algebra concepts, improves via these programs. So a little bit about Pirate Math organization, how the intervention is organized. We begin with an introductory lesson unit with 9 lessons. And these are the things we teach in the introductory unit. Definition of the equal sign, what the equal sign means, plus sign, minus sign. We teach addition and subtraction concepts using the number line and manipulatives. We teach children counting strategies that are efficient and reliable for adding and subtracting number combinations. We teach children to interpret data from bar graphs and pictographs. We teach children how to represent missing numbers, either using the X symbol or a blank line. And we teach children how to find what's missing when solving standard, when the missing number is in any of the 3 positions of a standard equation. We also teach children, as I showed you before, once they complete the introductory lesson, they have sort of a armamentarium of foundational skills that they will consolidate over the course of the Pirate Math full intervention, but that also gives them the foundation for learning now about word problems. So once we teach the introductory lesson, the tutors teach students to run through a problem, which provides students the first set of steps for approaching word problems, also slows down the student where they think about the narrative and build the problem model. And it also prompts students to look for and inhibit irrelevant information. And then we use posters throughout the program. This is the run poster that you see on this slide. And we always have 2 sides to a training poster. What you see which folds in half, So we should only show one side at a time. So we begin with the right side by showing the right side of this poster, which has the full strategy on there for children to use. Read the problem, underline the label, name the problem type, cross out the extra number, look for total, difference, change problems. We scale back as soon as we can to simplify the poster by showing just the left side of what you see up here. And we fade the entire poster as soon as possible and only bring it back as needed so that students learn to use the run strategy independently. So the total problem unit, this is at second grade, runs through lessons 10 through 18. Difference problem unit for the next 9 weeks, change problems for the next 9 weeks, and then there's a review unit. There's cumulative review throughout all the lessons for all the problem types that have been cumulatively taught throughout the 45 lessons. And we also, across the units, teach students transfer features that increase the complexity of the problems and stress the children's capacity to recognize problems as belonging to a known problem type. So we do this by teaching students to identify and inhibit irrelevant information, to locate relevant information in bar graphs and pictographs, to solve for missing information in all positions, and to solve problems that require more than one step. So they learn to solve problems which may involve a sequence of 2 totaling problems, or may involve a total problem and then a compare problem. So the problems get increasingly complex with more and more transfer features that press students' capacity to identify the problem type. Here you see an example of a total problem at second grade with 2-digit numbers. See what the student is using the strategy I talked about earlier, identifying the relevant numbers, identifying the problem type, using the problem type number sentence to find the missing quantity and labeling it with a $sign. Here are examples of a difference problem where we have the bigger amount minus the smaller amount equals the difference. So Pamela is 8 years old, Lynn is 15 years old. How many years younger is Pamela than Lynn? You see the strategy being used to identify the 7-year difference in years. Then on the right-hand side, you see a change problem. Pamela had 12 M&Ms, then she ate some, an implicit change verb. So she ate some M&Ms. Now Pamela has 4 left. How many M&Ms did Pamela eat? You see there we have the missing quantity in the second position of the change problem. Change amount is missing. The child solves for the 8 M&Ms that Pamela ate. At grade 2, we have 4 daily lesson activities in Pirate Math. We have a basic facts fluency building activity. We have a tutor-led word problem lesson. We have a Pirate Math game, which I'll give you an example of. The games vary from day to day. And we have Pirate Problems, which is timed independent written practice. And that all those 4 activities occurs in each lesson. Here's an example of a game. It's called the total game, where the student creates a total word problem to match a number sentence. So an example, the student draws from a pile of cards the numerals 4 and 7. The tutor places the 4 on the P1 box and the 7 on the total box. and the student makes up a word problem, like just to match P1 plus P2 equals T. In this case, it would be 4 plus P2 equals 7. The student makes up Giselle and Pamela have 7 pencils in all. Giselle has 4 pencils. How many pencils does Pamela have? So we have pirate math interventions at grades 1, 2, and 3. Those interventions focus on total, compare, and change word problems, and also addition and subtraction strategies. At grade 2, we have a coordinated whole class pirate math program, which has a tutoring program to go with it so that there's integration and coordination between how word problems are being taught in the classroom and in the small group interventions. We have fraction word problem programs as well. Fraction face-off at 4th grade, which uses a sports theme, and super solvers at grades 3, 4, and 5, which uses a superhero theme. And these fraction word problem interventions build fraction understanding and procedural skill, even as they systematically focus instruction on fraction magnitude understanding, fraction calculations, and fraction word problems. So at grade 3, our word problem intervention focuses on fraction, compare, and change word problems. So they're like the compare and change word problems I've been talking about, but they involve fractions, including mixed numbers. But that intervention is simultaneously teaching children about fraction magnitude understanding and fraction calculations. At grades 4 and 5, we have intervention on a greater variety of word problem types that involve fractions. That includes compare word problems, change word problems, what we call splitting word problems, and grouping word problems, which are multiplication and division word problems. This too also includes, the intervention includes instruction on fraction magnitude understanding and fraction calculations. So for example, at 3rd grade, if we look at the fractions intervention, there are 4 lesson activities, and this is the super solvers version of our fraction intervention. So we have the first activity in each lesson is called Problem Quest, where the focus is on multiplication, finding x by isolating the unknown on one side of the equal sign. So we're beginning to introduce algebraic ideas and word problems. So we have instruction in the first activity on word problems, multiplication, and isolating the unknown on one side of the second activity is called fraction action, and here is where magnitude understanding instruction occurs. And so children do activities like comparing fractions, ordering fractions, and at 3rd grade, placing fractions on a 0-1 number line. The third activity is Math Blast, which includes strategic, speeded practice. Sometimes it's on multiplication. Sometimes it's on identifying fraction equivalencies, trying to take that to a fluent and automatic level, finding, for example, equivalencies to 1/2. And also fraction comparisons, doing that on an ease basis through familiarity. And the final activity at the 3rd grade fractions intervention in each lesson is power practice, where cumulative independent practice is provided across current and previous topics. Within the Super Solvers program, students also complete what we call a super challenge every 2 weeks. So there's a 24-item curriculum-based measurement test where students learn to track their progress on the fraction curriculum that's being taught within Super Solvers. And so you see they graph their scores. There's every score every 2 weeks. And if you look at the bottom of the graph, you see these vertical bars where each of the main skills incorporated on each weekly test is being color-coded in terms of the student's performance, whether it was mastered, progressing toward mastery, or not yet mastered. And so the student can track their progress in terms of their overall score, as well as how they're doing on individual scores, individual skills within the Super Solvers curriculum. And we incorporate an executive function component as well. So for each upcoming Super Challenge, students select an overall performance goal for themselves, and they identify skills that they want to improve on in the next 2 weeks. And students are taught to link the importance of working hard. So this is kind of a grit emphasis for improving on the Super Challenge and on their classroom performance. And students are also taught to use the help strategy cards. Those are kind of like the posters I was talking about before, but only when needed. And they're taught to assist their partner and ask their partner for help when they need help. And they're encouraged to work hard and persevere through challenges, to self-regulate their talking, and to share participation with their partner in the learning process. So George had given me some questions to address. These are questions that I think school districts provided the JP DOS Center with ahead of our meeting today. And so I'll go through these questions. Are standardized word problem tasks available for use by school teachers to screen their students for word problem solving difficulties? There are not a lot of grade level word problem tests available commercially. There are research tools that that researchers often make available to schools and districts for them to use. We have tools at the primary and intermediate grades, grades 1 through 6. But there are things like, the main tests that I think of when I think of word problem specific tests is key math. The problem with a commercial test like that is it spans grade levels, and so you only get very few items at any particular grade. So those commercial tests can be difficult to use to screen students, to make fine-grained distinctions among students' word problem skill within a grade level. So it's good to consider contacting one of the main word problem researchers. There's a group of us across Canada and the States who may have something available for you. Are tier 2 or 3 packaged intervention programs available? The answer to that is yes, and I'll give you some links to go to on my next slides. And our online resources, similar to FSU's, the Reading Center's resources. The answer to that is yes. There are math interventions. There are websites that review math programs and word problem solving programs are included at those sites. Next question is, how early can we assess problem solving in children? Do you recommend we do it in grade 1? The answer to that is yes, and you can see why. That if we don't intervene early, that by the end of first grade, at-risk learners are farther behind, dramatically so, than on word problems than they began first grade at. So it's important to do early intervention in on-word problem solving. And has RTI been tested in mathematics? What tier 2 and 3 programs are evidence-based? For information on our evidence-based interventions, you can go to that website, or you can contact Lynn Davies at Vanderbilt. And for information on math interventions generally, there are a few nice resources. Here are 2 of them. The National Center on Intensive Intervention has an intervention tools chart. You have the link for that at the first bullet on this slide. And then there's also a nice review site of practices. It's called Evidence for ESSA. And that's Bob Slavin's site, where there's a lot of information on math intervention.